ships are designed to meet standards for safe navigation, and various safety technologies exist, but maritime accidents continue to occur. To respond to these maritime accidents, the Damage Control System, DCS, is configured to quickly and accurately manage fire and flooding incidents on ships, providing appropriate procedures and enabling suppression. In the military and maritime sectors, this is known as the Damage Control System, DCS. The Maritime Autonomous Surface Ship Damage Control System, through the Digital Bridge, enables real-time monitoring and quick response by linking the ship and the Shore Control Center. Automated equipment ensures immediate response to accidents, and remote control and shore support contribute to safe navigation conditions. The Maritime Autonomous Surface Ship Damage Control System. The damage control system is configured based on the ship's general arrangement and allows monitoring and control of the status information of various heterogeneous sensors. This is the first screen displayed when the user runs the software. It checks the time of the accident on the ship and automatically saves the system's status. Based on the general arrangement, the arrangement of fire sensors on the ship and whether alarms have been triggered can be checked. When a fire occurs, an alarm is generated for the sensors in the affected compartment, and a pop-up providing information about the fire compartment is displayed. In the event of a fire accident on an autonomous ship, the screen displays the fire compartment, available evacuation time, and safe evacuation route information to guide the crew. The location of necessary equipment for fire situations is displayed in the legend. The operator can select or remove equipment locations using check boxes to manage and visualize equipment location information effectively. During the response, ISO 20232 fire symbols can be entered. The type of fire can be identified via a pop-up, and the results of fire spread can be checked to monitor the spread of the fire and smoke. The damage control scenario is based on procedures required by relevant regulations and includes a two-stage algorithm designed to efficiently suppress a fire in the event of an onboard fire accident. When a fire first occurs, the crew is guided to attempt suppression and make announcements as well as notify relevant authorities. If no crew members are on board, this step is skipped, and the first fire response procedure is initiated immediately. This involves isolating the fire zone, cutting power, and attempting to suppress the fire by activating the fire dampers, ventilation, and sprinkler systems. If suppression is deemed unsuccessful, the second fire response procedure is initiated, repeating the same process. In the event of a flooding accident on an autonomous ship, the system switches to the flooding response procedure screen, where the necessary steps are carried out. When an accident occurs, the screen displays the flooded compartments, divided into port and starboard, allowing the user to immediately identify the location of the flooding. The response procedures are then carried out according to the damage control scenario. First, the response team proceeds to identify the flooding location and scale. If confirmed as a flooding accident, the response team is deployed on-site, an emergency broadcast is made, and relevant authorities are notified. If no crew members are on board, this process is skipped. The danger zone is then sealed off, and the flooding is managed using electronic control devices, such as drain pumps, bilge pumps. Subsequently, the system assesses the ship's ability to navigate on its own and reviews the vessel's stability. If necessary, evacuation and rescue requests are initiated. All these procedures are recorded in the alarm log, allowing for later review to determine the appropriateness of the response. During the response, ISO 20232 flooding symbols can be entered. The entered flooding symbols can be reviewed via a pop-up, and the system is designed to easily monitor the flooding response situation. Once the operator concludes the flooding response scenario, the system allows for checking the results of the flooding spread. Through the operation mode, the connection between the damage control system and the damage flooding prediction display module can be controlled, and damage behavior can be simulated by entering relevant information. The system simulates damage behavior using damage, flooding, and sea state information. This function allows the user to monitor the current simulation time, wave height, and 6 degrees of freedom (6DOF) motion based on the simulated damage behavior of the ship. The function displays ship motion index info, which helps assess the ship's seaworthiness and the crew's operational efficiency. The motion judgment is displayed as either normal or attention based on predefined standards. This function simulates the visualization of ship damage behavior, allowing the operator to intuitively observe the ship's damage behavior through the visualization screen. Additionally, graphs of the ship's 6 degrees of freedom (6DOF) motion are provided to the operator. The autonomous ship damage control system is operated via a console with embedded software to manage incident response on the ship and communicate with the Shore Control Center. The hardware configuration of the damage control system console includes the following components. The flooding sensors required for accident response have been designed in digital form, replacing the traditional analog format, establishing a comprehensive measurement sensor system. A hotkey module system has been implemented to symbolize complex and challenging procedures, enabling immediate accident response. The innovative technology embedded in the autonomous ship damage control system is an advanced system designed to smartly respond to any situation, evolving into a technology that will protect our valuable lives and assets.